Um, Thank you everyone for joining our today's event. Um, Today's in good morning and good evening, depending on your location where you are. TechForm is TechForm is arranging technical events from last 11 years, and we are very much grateful to our speaker pool who are doing great job. Voluntarily, they are giving they are attending, they are not taking sessions, and they are not, I think we believe that they are not only the expert, they are not good in technically, but they are very much good human being. So they are taking voluntarily many sessions for the professional community. And our community motto is to share and learn. And today we have 4 sessions, and the first session is on the application development, and we are inviting to Asif Waquar bhai to start his session. And Asif Waquar bhai is, we are very much thankful to Asif Waquar bhai. He is taking many sessions in last years and even today, and we are just going to invite Asif Waquar bhai about his event. Asif Waquar bhai, are you there?
Yeah, I'm there. Thank you, Hasan bhai, for inviting me and for your kind words. And I'm very thankful for of you for giving me the opportunity for to present today. And we are thanks Hasan bhai and team for organizing this session. Without them, I think it was not possible. And guys, today I'm going to talk on the topic of build serverless app using Cosmos DB and Azure Functions. A little bit about myself. My name is Asif Waquar. I'm a Microsoft MVP and cloud solution architect in ABN AMRO Bank, working in Singapore. And so, good afternoon, everyone. And if you're good afternoon or good morning, means from wherever you are seeing this. And so today I'm going to talk on the topic of Cosmos DB, basically. So Cosmos DB is a NoSQL database provided by Microsoft Azure. And why we are discussing basically the NoSQL databases, and is what's the need of this session and what we'll get by end of this session, what you will learn. This is a very introductory session, but by end of the session, you will get an idea how you can build an event-driven app using Cosmos DB, which is a NoSQL database. And about the NoSQL database, what actually the NoSQL database is. NoSQL databases are basically designed for distributed apps, which is scalable more apps. If you talk about 90s, we have a relational database basically, and relational databases were designed based strictly for more for the structured data, and NoSQL databases are solving the problem of basically we can say is 3V, like volume, variety, and velocity. What it means by volume, variety, and velocity is means we can basically when we talk about the volume, variety, and velocity, suppose you are means the relational database, when we have a relational database and we want to means we are getting a large volume of data, and the data is not structured data, and it's kind of there are a lot of variety of the data we are getting, and the data which we are getting in terms of it is having means large amount of data, means there is a data spike sometimes we are handling. So in that kind of scenario, our relational databases are not enough. So how we previously used to handle the data is based on the CPU, memory, and the more and more machines for the relational database case. But at certain points, we cannot add more and more machines, right? So in that kind of scenario, we need to scale up the application or databases. So there is only one thing remains is scaling out, and that can be done by handling a database which can fulfill all the needs of handling volume, which can handle a large amount of volume, which can handle a variety of the volume. Means like suppose you are getting a data which is not a structured data, like in terms of Facebook post or social media post. So if you see in that, we don't have any specific the structure of the data. And like what it means by velocity is velocity. Suppose you have some on shopping cart website, you have some Black Friday sale or something, so you will get huge traffic on that period of time. In So that kind of scenario is really difficult to handle with relational database. So that's why we need NoSQL databases. And so what exactly the NoSQL databases are doing is solving the problem of the big data, which is volume, variety, and velocity. So relational databases in 90s were not exactly designed for the solving of the big data problems. So, so how it is different from the relational databases? Let's see how we can see. In relational databases, we used to have rows, columns in our structured format of our tables. We used to have rows, columns, and strongly typed schemas, like which is highly normalized. But in non-relational databases, which NoSQL databases are having, we have a document, we have properties, which is schema free, means we don't have any particular structured table, and this is completely denormalized form. So if you can see here, we have a user table, and user table in relational database, we used to define like user ID, names, date of birth, and we used to have related tables like which we used to add by a foreign key, like stock user ID. So we used to relate like that. But in document database, what we do is this is a NoSQL JSON format. NoSQL databases are basically, especially for the Cosmos DB, it's in JSON format. So you can see that we don't have any specific structure table. We have ID, date of birth, holdings, all, and we can add as many suppose properties later on if we need it. So suppose you are getting some data which is not structured, like your post. So you can add as many properties or columns in the NoSQL database. That's the flexibility of NoSQL databases. So let's see what in which scenario we will use NoSQL databases. Like if you are getting frequent large activities like IoT data. So suppose if you have any IoT devices and you are capturing the like RFID tag example. So if you are capturing RFID tags, tax information, suppose. So the tax information is basically sometimes with the tax information you will get some information which is not relevant to the tag reference ID. So in that kind of scenario, we cannot handle all those information in relational databases, and that will be best suitable for the NoSQL database, because we can capture all the event or all the information, and then we can filter out those information from by using the NoSQL databases. Like gaming also don't have any structured format or data. So that kind of data is obviously a no good use of NoSQL databases. And the e-commerce website. E-commerce website, suppose you have a e-commerce website which is running in multiple regions, like maybe you have running in Dhaka, you have one same e-commerce website is also in Singapore or US, or in multiple regions you have an e-commerce website like Amazon. So how means like suppose we have a Black Friday sale or some other important event, and in that event there is a spike in the traffic. So the databases should be able to handle such activities, right? And if some product is buy from those websites, from US website or from any website, so that product information should be updated on different regions. So that kind of scenario we can handle with the help of NoSQL databases comparatively easily compared to relational databases cases. Even though Microsoft is using a lot of products, the NoSQL databases, Cosmos DB, which is in Spike, Skype, Xbox, Microsoft 365, Azure, and more. Uh, more of their products, they are using Cosmos DB as a backend databases. So in Microsoft Azure NoSQL databases, they are providing Cosmos DB, which is a part of Document DB, and it provides a lot of really good features in terms of turnkey global distributions, which it means is if means with the help of means within few clicks you can replicate your data from one region to another region. Suppose I am going to create a Cosmos DB instance. Cosmos DB means for Southeast Asia region. So my data will be available in Southeast Asia data center. But now I have a requirement. I want to replicate this data because it's my shopping cart website or some other website. I want to replicate this website in some other region or data in some other region. So within a few clicks, we can replicate the data. I will within a few minutes, I will show you how exactly we can do that. And elastic scale out, storage, and throughput. Uh, it is that Cosmos DB helps to provide a feature is you can automate, there is auto scale feature. So if suppose if there is a spike on certain period of time or means at certain hours, it will be auto scale feature. So it will be automatically scale out all the Cosmos DB replicas. So it will be handled, it will be able to handle such requests. And it provides elastic scale out and storage and throughput, and then it provides a low latency means of 99%, right? Means how much time my data will be available in some other region. So with the 99.9949 percentiles they provides, and it provides also a consistency level of 5 for different consistency levels. In going forward, I will show how what are the consistency levels more in details, and about the SLA. And about the Cosmos DB, the best feature is you can handle a request of multiple data types. Like it provides APIs for different types of databases. Like it provides API for the Core SQL and MongoDB, Cassandra, Table API, and Gremlin. What it means is, suppose your data is in MongoDB, your current application is MongoDB application, and you want to access that data using Cosmos DB. You want to see the data or you want to generate some report. So with the help of Cosmos DB, MongoDB API, you can leverage those features and can access data in Cosmos DB. Core SQL is generally available for all, and it is you can say advanced version of SQL, and you can access the SQL data also in the Cosmos DB. And same as it is for the Cassandra and table APIs. Table API is basically the structure format of Azure table storage. And if you have application in Gremlin, so yeah, the Gremlin database is also you can access from the Cosmos DB. These are the few features, like it provides a key value and document and graph and family of columns. It provides a 99.99 percentile of low latency, and ensure the availability of the data, consistency of the data until 3 nines or 4 nines. So yeah, I will just skip this part, and it also provides automatic indexing. So all the different APIs having different features. I will explain more in details in going forward. So how you can start with Cosmos DB is you can basically sign up a trial for 30 days, and you don't need a credit card for 30 days trial. And it also provides Cosmos DB also provide a local emulator like Cosmos DB emulator, and we can do the development using Cosmos DB emulator. And suppose if you have Cosmos DB in Azure Online, you can connect with the local emulator and perform all the activities. And for knowing how much it will cost, there is a capacity calculator. I will explain more in details about how we can calculate how much cost will be, and how much, because all the capacity calculator basically it helps to identify that how many requests you need, because in Cosmos DB all the requests are based, means like whatever the data transactions you will perform, it will be based on request unit. And so there are two ways we can calculate that. There are provision throughput, and there is a second way is the serverless. Provision throughput is like a dedicated throughput assigned for your Cosmos DB emulator, Cosmos DB, and serverless is for, like, suppose if you have a small workload, so serverless option is for that. I will show in details. About once we are going for, I just want to cover up a few basics, then we'll see everything in detail, more in detail. For calculating, for creating a Cosmos DB account, so how exactly, well, you need to go in Microsoft Azure portal, and in the databases you can see the Cosmos DB. And at a certain level, this is cost means for creating an account, you need to have a Microsoft Azure subscription, and you can go and create from the databases. In one database, in you can have multiple containers. So don't compare the containers with your tables, like it is not like that, because it is a document database, and in one container they will have multiple documents, which is called items here. And related to Cosmos DB API, so there are 5 types of APIs Cosmos DB provides. One is Core SQL, which I already explained. So Core SQL is a native API for Cosmos DB, and it is, you can basically view your traditional document store data with help of Core SQL. So most of the cases we will use the Core SQL APIs, and it is basically for the usage part. As example, you can see the in shopping cart website, like we have a product catalog. So, and you means like for that kind of scenario, you can create a APIs using Core SQL APIs for Cosmos DB. And same for the MongoDB. Suppose if you have an existing application which is running on MongoDB, and you want to access those data, so you can, this is good for, you can access those data by using Cosmos DB API for MongoDB. And this is good for importing historical order of the data. Like suppose you have in shopping cart website, you have a data which is historically, it's like for 4 5 years, 10 years data. And that kind of data can be good fit for MongoDB API, you can use for retrieving those kind of data. And if you have means application data, means like you want to perform some analytics, so I think Cassandra is API will be helpful for doing that. Same for Azure table, means like if you have data like you are collecting from IoT sensors, I think then you can store in Azure table. But for Azure table, means you can also store in you can Core SQL API, which is more rich in features in terms of compared to Azure table. So both are almost similar, but Core SQL is more in terms of better in terms of features. And Gremlin API. So suppose if you want to build some kind of recommendation engine or something, if or you have already uh, existing application which is running on the graph database or Gremlin, so you can use this API. And suppose we have seen in the shopping cart website, there are some recommendations when we are accessing any means like seeing any products, so we will get the recommendations. So in that kind of scenario, Gremlin APIs will be very helpful. You can use for recommendation engine. So how exactly it looks like? So one databases can have one or more containers. So, and one containers can have multiple documents where all your data will be saved. You don't need to worry about structure of your data. I mean, it can be in any format. Uh, but it means, so in containers can be like a collection graph or table, like based on which API you are going to choose. Suppose if you are going to choose a SQL API, so it can be collection. If you are going to choose a graph API, so it will be in graph format. If you're going to choose a table, so it will be key value pair. So based on the which API you are going to choose, it will be uh, yeah. So collection API, all the data will be stored in terms of document. Graph API, it will be vertex of edges. So because it helps to maintain the relationship. And table APIs will be rows, key value pair columns. And at the database level, in the items, we will have store procedures, triggers, user-defined functions, and conflict feed. What it conflict feed is, suppose if you have means application which is running on two different regions, and by performing read and writes on two different regions, like suppose if you have buy something or bought something, and similar transaction is performed in some other regions, so which region will take effect first, or means it will be show you out of stock, or means suppose we are going to buy something on sale, and sometimes suddenly it shows out of stock. So yeah, means like how exactly the transactions are happening in the backend. With the help of conflict feed feature, it helps to resolve those conflicts. So in means like which region read and write will be performed first. In maybe in upcoming sessions, I will discuss more on when we will discuss more on the geo means geo replication feature. Then we will talk about the conflict feed. Conflict feed is basically for your understanding as of now is to resolve those conflicts in two different regions for the read and writes, means which read and writes will be performed first. About when we're talking about the items, so there was store procedures, triggers, UDF, and there's also one called change feed. So when we are talking about the building event-driven functions, so event-driven or this kind of app are basically defined for is using store procedures, triggers, user-defined functions, or change feeds in Cosmos DB. So user-defined functions are basically means like what the functions you are going to build, like using Azure functions, or change feed is basically the external. Store procedure, triggers, and user-defined functions are internal functions, and change feed is the external. Like in a common word, I will say is change feed when you are going to means when there is any changes going to apply on the database, Cosmos DB database, like saving or retrieving. So that can be captured by using change feed, and change will appear at once. Like suppose you are going to collect the data of from IoT sensors. So in IoT sensors, you are going to collect the data in real time basis. In that kind of scenario, change field will be helpful because it will capture the data at time and process the data to reflect it. Although store procedures and triggers and user-defined functions will be execute based on how different conditions, like store procedures will be restricted to our partition is in the database. In NoSQL databases, how the data is saved, because it's all document and there is no tables and the columns, such kind of things. So the database data is saved in terms of initially what it will do, it will create the partition in the databases. Like for suppose you have four departments in your organization, like one is marketing, one is sales, and one is means accounts. So for each departments, there will be different partition in the Cosmos DB. Means like there will be partition key basically, and based on the partition key, all the data will be stored in that partition. And if that partition is filled, so automatically Cosmos DB will help to replicate that scale, that is called auto scaling feature. Auto scaling or scaling is dependent. Like you want to do manual scaling or you want to do auto scaling. It depends on you and yeah, your requirement. So yeah. So execution means store procedure will be execute based on the partition. Like suppose you are going to execute some kind of procedure for your accounts department or marketing department. So you need a partition key for that partition, and it'll execute in that region only. It is same exactly means like suppose you want to perform some action in particular database or particular table. So the store procedure you need to define right in the relational database. So it is similar to that. And triggers will be executed pre and post. Like in pre triggers basically handle the data transmission of or validation. Post trigger will be like based on aggregation or change in notification. So suppose you want to perform some actions before submitting the form. So the pre-triggers will be applied on that, like data transformation or validation. Means like there are some validation at the database level. So pre-triggers will be helpful, and post-triggers will be based on your suppose if you have performed some transaction, but that product is already sold or something. So post-triggers will work out in that kind of scenario, and it will notify that. Triggers are generally not guaranteed to execute, but based on the specific request. And if there is any error happening, so post trigger will work out and it will roll back the transaction. Yeah, I'll not. Yeah. So about in Cosmos DB, there are 5 consistency level. Means like strong, boundless, session, and eventual consistency. So it depends on means like what is your requirement. Suppose if you want means like suppose there is any financial data, and you want you don't you are not worried about the means like availability, means like if of the data, means like when it is available, but you want the accurate information. So in that kind of scenario or API, you can choose a strong consistency level. But if you want means data which is based on your session, like when the user is logged in and when the read and writes are applied for that session and he want to see those to be reflected, so that should be in the session database. You can means like set the consistency level as session database. And eventual is you means like which is weaker in consistency and low in less latency and but high in availabilities. You want the data to be highly available in different regions, so you can set up the eventual consistency. So it based on your requirement how you want to set up your consistency level. And Microsoft Cosmos DB provides you 5 consistency level. And how it replicates, so data moves extremely fast between the neighboring racks, like maybe within 1 milliseconds. And if you are choosing the geo replication feature, so it will take 100 of milliseconds to replicate your complete data to other region. Yeah, so partition basically when I was how we are going to save the data. So saving the data was basically for means there are different types of partition we do in Cosmos DB, like logical partition or physical partition. Cosmos DB basically distribute the logical partitions into smaller physical partitions. What it means by is we are going to save the data. Logical partition is nothing but store all the data with some partition key, means some kind of like suppose you are going to save the data with customer ID, right? So with the you are going to identify each customer with the customer ID. So that is the kind of logical partition you have made in while creating the container. And then you are going to save the data. Means suppose you have choose the database storage like SSD or compute, and based on that you want to auto scale. So that will becomes under physical partition. So we can define a partition key, one partition key per container. So in one database, we'll have multiple containers, and how you are segregating your data, it's your need, based on your need. Okay. Let me just go and first explain how maybe in the suppose if you want to go and create a Cosmos DB account. So So what we are going to do is we are going to show a two basically things. We are going to build a two APIs. One is how we are going to capture the data like real-time data using change feed of which is event-driven means like suppose we have application which is going to get the data from the IoT sensors. So with the help of Cosmos DB, how we can capture those data with the help of Cosmos DB and change feed feature. And second, we will see that if we want to build an app, which is build an API basically, which is a HTTP based API to perform some kind of transaction of your shopping cart website. Suppose you want to you want to see the product catalog, you want to create the customers, you want to see the how many products you have. For those, what kind of with the help of Azure functions and Cosmos DB, how we can build such APIs. So these two features we'll see. So before going to, yeah, let's see in if you before coming to here, you need to have a Azure subscription. If you are means you will get a 30 days subscription for that, and you need to go into the database. You will get the Azure Cosmos DB. So basically, Azure Cosmos DB, as I explained, it is a NoSQL database from the Microsoft Azure. So let me, I have actually was already creating. So let me go and quickly create Azure Cosmos DB. In subscription, whatever subscription is a free trial, if you have, you can choose. You can create a resource group, or if you have already existing resource group, so you can choose. And I'll not go more in details in this because I think if capacity mode is provision, throughput, and serverless. So these are the two throughput mode is capacity mode are available. Provision throughput is means like dedicated for your request. There is a dedicated means like the throughput assigned for, like, suppose you have 1,000 RU per second. So how much throughput will be? That will be more on the mission critical databases. Suppose you are running some production workloads or such kind of, so you can provision throughput based on your capacity. And serverless is more on based on the request base. If you have small workloads and you want to do that based on your request, so you can choose the option of serverless. By default, means like, because it's not my first account, so that's why it's showing apply free tier discount is showing gray out. But if you are creating first time, so this will show you apply or don't apply free tier. Free tier is like 1,000 requests per second. If you 25 GB of storage is free, so you can choose apply, and until unless you don't use 25 GB, it will be free of cost and you can use it. Next comes is the global distribution. Suppose you want to replicate your containers data into two different regions. Currently, I'm going to create in Southeast Asia Central region, but I want to replicate the data in West US region or some other region in the US itself. So we can choose this feature as a geo redundancy and redundancy. And there's also option for multi-region writes. Suppose you want to only enable the read writes for that region. You don't want to perform the write operations there. Means like, suppose you want to only see the information for means like means suppose you want to see the information which is more on how we are going to get the customer information or product information, but you don't want to see perform any writes there, like you don't want to create the products or you don't want to perform any writes action. So you can just disable it, otherwise you can enable it. For the networking, by default, it's a public, all the networks and public endpoints, but you can also create a private endpoints if you want to create. Means you can in your own VPC network or VNet. And backup policy, you can choose a periodic or continuous. Periodic is like based on your 240 minutes, or means like it provides for the days, like for maximum how many days of backup retention you want and how many minutes or hours you want. And suppose if you want a continuous backup or periodic, it depends on your choice how you can do that. So I will quickly go and create encryption. It provides encrypted data uh, in your data centers. Okay, so let's go and quickly create. So it'll estimate time is 2 minutes. It'll go and create. Okay. Until then, it is going to create. Let's jump to the slides and see what we can do more to build event-driven apps. For with the help of Cosmos DB, with the help of change feed features, which I'm going to show in the demo as well. What we can do is we can capture the data from multiple sources in Cosmos DB, and with the help of change feed features, we can process the data in using Azure Functions or Service Hub. Oh, sorry, wait, I think my screen was already shared, but
No, it's okay. And now your screen is shared.
Yeah. So we can yeah, so with the help of means like we can get the data from the multiple sources and Cosmos DB change features. So you can see there the in that means like we can use in real time and gaming by using Azure functions or Azure Notification Hub or service. With the help of stream analytics, we can process the data for the gaming and for the big data and for the reporting purpose. And we can also with the help of zero downtime migration, we can process the data into storage table or data lake or maybe. Second means like there is also a feature called input and output binding. Means like when there is a change feed. Okay, so we want to save the data means with the help of change feed is nothing but basically a Azure Cosmos DB trigger. So suppose you want to save the data real time basis, so we'll use the Azure Cosmos DB trigger or you can say change feed features. But if you want to get the data from Azure Cosmos DB. So what we will do is we will use the input binding feature, which is nothing but our HTTP with the help of Azure Functions HTTP trigger. We can get the data means from Azure Cosmos DB input binding. And if we are means like going to write the data, suppose if you have a means shopping cart website and you want to create a customer in that. Okay, so with the help of output binding, we can write the data in Cosmos DB. So output binding is in general terms we'll say is output binding is writing the data and input binding is getting the data from Cosmos DB. And both can be achieved with the help of Azure Functions HTTP trigger in Cosmos DB and Cosmos DB. So in general terms, if you see, this is means like an example. Suppose if there is a customer who want to check out, so he like will use the input binding triggers to get the customer informations from there. And suppose if some customer is going to going to buy something from the shopping cart website. So in that kind of scenario, he will use the change feed feature, which is a DB trigger for performing. Suppose he have added some, he have buy some product. So that product will be added into their cart, and that we can capture with the help of DB trigger, which is change feed feature. And with the help of auto binding, we will save the data into the database. So item will be added and item will be added here, and with the help of checkout means we use again Azure functions and will perform the actions. So all this action will be performed. I think there are three ways to perform means like either change feed features or input or output binding in such kind of scenario. But there are different triggers as well in templates. I will show you while creating the Azure functions with the Cosmos DB demo. Sorry. So now my Cosmos DB is all ready. You can see here in we have a data explorer, so you can see all the data from Cosmos DB. Means we can create a new containers first. Means container is nothing but I already explained in one database we can have multiple containers. So we are going to create for the shopping cart. So we are going to create a web store, and there is a database feature for auto scale. You can perform also the manual scale. Let me just close this. You can perform auto scale feature or you can do the manual scaling. In auto scale, you don't need to worry about your storage. It will be automatically scaled based on your request unit. And if you want to perform a manual, you can do that, and estimated cost will be based on like are you how many requests you are going to perform. And there is a capacity calculator. Maybe I will provide the link later on. So it's like, suppose if you want to perform the manual, you can calculate how many, I mean, which region you are going to choose. You are going to choose the multiple region writes or read, or means based on that you can choose the manual, or going to use the auto scaling feature. Okay, customer ID, because as I told earlier, in NoSQL databases, we have to create the partition, and the partition is based on the partition key, and we are going to create a collections like items, because in each container there are items which we are going to store our documents. So we are going to store the customer information here. But suppose if you have multiple departments, so you will have different containers like for each department. And for my, I'm going to create for the customers. So my ID is customer ID, or just ID I can create. And if you have any other foreign key or unique ID, you can specify here. And there is also a feature called Analytics Store. You can choose the Azure Synapse Analytics for performing any analytics features on Cosmos DB account. And there is also called Notebook feature, I think, which is currently not available because there is some issue with that Notebook feature. In that also you can see the means you can specify like all your Power BI or analytics for your Cosmos DB account. So it's going to I'm going to create a new container, and until the container is going to create, so let's go and create a. So what we are going to do is, first we are going to create a Azure functions, which is going to capture the all IoT or real-time data from Cosmos DB. So suppose if we are going to let's create a function app. Function is at function demo one. Okay, I'm going to runtime stack. I can choose a .NET, or if you are familiar with Node.js, you can choose that. And the region I have choose Australia and Central. Okay. My Cosmos DB account is so miss. You can see here in web store. I have this is my container web store, and I have items in the this is my customer. I can also create more containers, like I want to create containers for suppose some other department, like I want to create for means finance or some other. So I can provide the ID, and based on that, it will create one other partition in the same database. But for now, I am going to create only for the customers. Okay, and these are the means like let's go and create a new items. So you can see here my one. I have actually already. I'll just copy my old Cosmos DB some data from here, the Explorer. Actually, ID can be unique. It means like whatever is your choice, you can do. Let's just. So you can see here, okay, I think because I'm going to update the ID. So because ID will be always unique, so we cannot update the ID. So that's why let's try. Okay, it's updated. Now let's go and create a new item and replace it with manually 3, 4, 5. So so in my function app is already created. Let's go and see in. So what I'm going to do is I'm going to capture if any records I'm going to create in this web store database, which is customer. If any customer is added here, I'm going to capture this data in real time basis from our Azure Cosmos DB functions. So I know I have a few minutes remaining. Just so if you can see here, there are in Azure functions, there are multiple templates available already, like HTTP trigger, which is used for input and output binding, means basically for exposing the HTTP request. And there is a timer trigger also. Suppose if you want to schedule, like suppose you are uh, getting some email and after some time you want to perform some actions, you want to create a ticket, so you can use this timer trigger. Or there is also queue trigger. Suppose you are receiving a data which is in a bulk amount of data from multiple sources and like IoT data, and you are not able to handle the request at a time. So you can use Azure queue storage trigger. You want to store the data from a particular region by using queue, Azure queue storage, and then perform some actions. So we have already like we have a blob storage trigger. I'm going to use Azure because I'm going to see the Azure change feed feature, which is Azure Cosmos DB trigger. So let's see Azure Cosmos DB trigger. So let's go and create for spread. Oh, so it is going to ask the connection. So suppose if we have already new connection or existing connection. So we have Azure Cosmos DB, which is our is a demo we're going to use. Database name is web store and collection name is customers. Because and suppose if you have a different collection name, like you have finance or you have marketing or whatever, so you want to perform the actions on that, you can define there. And so let's go and this is lease, like basically if you can see the name of the collections to store the leases, so it will create a means like a lease for this collection. So it will kind of, you can say, they replicate the data. So let's see. So what we are going to see here is means actually this Cosmos Azure functions you can also write from the, if you have VS Code, you can write from the VS Code extension, or you can directly write in the portal and test. But I think for this demo purpose, I'm going to show from the Azure portal, because while I was creating the Azure function template, so there was option for choosing the like let me show you. There was option develop in portal or VS Code, or so these are the options you can choose for the template. Code and test. Okay, so we have created a Cosmos DB trigger. Basically, And what it will do is, like, if there is any documents modified in web store database, because we have already created the connection for that, so it will identify and it will show the document ID. These two functions it will do, and it will do on the real-time basis. Like and when we are going to perform this action, we are going to use the master host key, because these are the function keys which is basically used for your authentication purpose. So yeah. But if it's the same trigger, if you are going to create from the VS Code, so means what you need to provide is, you need to create in VS Code, you need to create the, like, Cosmos DB trigger, whatever the function name. You have to provide the database name and collection name and whatever the connections you have created, and lease connection, and then means like document modified or whatever the logic you want to write, you can write for the trigger. So let's see, because my I think it's accepted. So let's go and create a new document and see if that is captured or not. Step 3 ID is something, whatever. So we need, so you can see here, this, whatever the actions I have performed, is like a new document is created in the Cosmos DB and it is captured. So this is how it works, like collecting the data from multiple IoT sensors, uh, means like on the real-time basis. So if there is any change in any property, like suppose I want to update name, or I want to add some so it will capture, and you will see there is a document is modified. Now it is modified, and document ID is this. And suppose I want to add one more property, so we don't need to create a new column for this. I can create a new property column here, and I can just like update here. So we can capture unstructured data with the help of then it will show that this again it is updated. This is how the change feed features work. And now let's go and create the same thing. If you want to create, uh, the data in Cosmos DB, like suppose if you are, so miss like we have discussed like input and output. We have discussed three ways. Like one is the change feed feature, one is the bindings, input and output binding in the shopping cart website. So now I want to get the, means like I want customer want to do the checkout. So what we want is customer information from there. Or suppose we want to buy some product. So what you will do is you will use the output binding. How exactly it will work is, let me show you. I want to create the customer. So what I will do is I will create a HTTP trigger, which is create customers. Okay. And yeah, I've already actually for speed up, I have already created one. Let me just copy paste and then explain what exactly I'm doing there. So I will replace the code of creating the customer in my output binding function. So what I want to do is this is for creating the customer. So what I'm exactly doing is I want to store the four properties in customer data document, like ID, customer name, address, and means like how much is the total amount, means like customer or amount, whatever. And to run this, there's means like based on the HTTP request, what I want to get is the output document. Means like this is the output. You can specify whatever the document you want. Means like you want to get the data of output. So this data I'm going to get as a from the body request body, and then I'm going to deserialize this request and get the output information. So let's save and see how exactly it works with the Cosmos DB. Now I want to create a customer in Cosmos DB, right? So first of all, in integration, you will see there is a HTTP. First of all, this is the HTTP request we'll get, and we'll create the customers, then we'll get the output. We are going to create the output trigger. So in the output, we are going to create where, suppose you want to create store the information in like related to customer, like suppose customer profile. So you can use the Azure Blob Storage. But suppose if you want to store only the data, so you can choose the Azure Cosmos DB, or it's like whatever. Because I have specified my document parameter as an output document, which is my output parameter. But the database name was web store. My collection name was customer. Suppose if you want to store in different collection, you can use here. And partition key and all those are optional parameters. But if you want to store in some particular partition, you can specify there. Now it is updating the information. What I want to do is let's go and test this. I want to create the customers in web store database, which we have earlier created. So currently I have 4 properties. So let's quickly go and replicate the 4 properties there. Asan bhai, I have just 5 minutes more. Try to finish that.
Okay, Asif bhai.
Sorry for the delay.
It's okay.
So this is my first customer I want to store. The customer name, maybe like Azure, suppose. Address. Dhaka. Total. So this is the post request because we are going to save the data into the database as a Cosmos DB. And let's see here. So just refresh it. So now you can see here we have another record came, which is Azure Dhaka, and we have saved as a. So we don't need to, in customer collection, if you can see here, our collection properties are completely different. Means like we are not bounded with the table structured columns and rows. Means like we can store any properties based on our requirement and need. And now what I want to do is I want to retrieve these information. It's like suppose this was the output binding feature. Like suppose we have added the cart or item is added in the shopping cart website. Now I want to get the information for the checkout. So what we'll use is we'll use the input binding feature. And these all the informations what we are capturing is we can capture. Let me parallelly show you change feed feature also when we do that. So when we have added the customer, okay, now let's go and again add the another customer, which is Azure 2, and it is Singapore. And now I want to capture this in my change feed features also. Yes. When the customer is created, so it should be captured in change feed. And this I want to get, I will create one more function to retrieve those information. To retrieve these informations, we'll use the input binding. So let's quickly create one more for getting the customers. So what exactly I'm doing here is, if you can see this customer information, ID, customer name, address, parameters, I'm going to retrieve from the customer list. And this is input document. So you can see here, this is my input binding feature. So I will configure the input binding here. So this Cosmos DB, and you can see the parameter name is input, and the database name I will web store. Collection name is customers. This we are because we are going to get the data from there. And let's go and quickly create. Yeah, now my input binding feature is also ready. Let's go and quickly run it and see, because this is my get request. So I will. So you can see here, all our documents are, all our customer information is retrieved. Now what I want is, I want to create the customer Azure 2, which is Singapore. And I want to see this is captured here or not. So you can see here, function customer, the value cannot be null. Okay. Oh, I haven't passed any parameters here. This cannot be deserialized name value. I think there is some problem in my function. This cannot be serialized. Okay, I think maybe I will check it why it is not happening. First of all, once we have created the output, once we have created the customer using the output binding function, then we can see here our in this information is retrieve or not. So you can see here, with this help of Azure 2 Singapore, we have already retrieved the means. So in general terms, basically the output binding features are used for saving the data, basically for the write operations, and input binding features are used for the read operations for getting the data. And Cosmos DB trigger, which is for change feed features, is used for capturing the live data or streaming data for this purpose. And maybe in upcoming sessions, I will go more in deep in terms of change, because change feed features is a quite big topic, and how we can do the partitioning to get the real-time information from different sources. And yeah, that's yeah, and how we can build the APIs or design the APIs using all these three features and functions, change feed features or Azure functions. Yeah, that we can cover in maybe coming topics. So that's for today. And we have, I mean, there are some important links like for pricing calculator and SQL query, how you can use the SQL query, uh, for the Core SQL APIs, and with the Cosmos DB emulator, it's like how you can configure your Cosmos DB emulator in your local. And suppose if you have already data which is on SQL Server database or some other, so how you can migrate to Cosmos DB. There is also a data migration tool. All these links I have provided. Maybe I will share these slides later on, and then you can see. That's for today. Somebody, you're there.
Asif bhai,
Okay,
thank you very much.
actually I'm 10 minutes late.
Actually, it is very much interesting session. I feel people will be happy, and I think we need many more session on CosmoDB actually, so people will be feel
Yeah, actually,
okay.
it's a quite vast topic and very interesting in terms of like global I mean, replication, and how we build the complete system with the event-driven apps using chain feed features or APIs. There's just very interesting topics. In 1 hour topics, I could not cover everything, but yeah, I tried to touch each topic. Maybe in upcoming sessions, I will cover more.
Thank you, Asif bhai. Hopefully in June we will uh, arrange another one session.
Thanks. Sure. Sure, inshallah.
Thank you, Asif bhai.
Thanks, everyone.
Thank
Thanks
you very
for
much.
thank you, Hasan bhai, for organizing this.
Thank you very much again once. Uh, Move on to our next session. To towards the all of Karim is there.
Yes, sir. Very.
Hi. How are you? It's a long time
It's
after
good,
that
sir. Yeah,
we have met.
it's very long time.
And I think in 2018 we have met in Seattle, right?
Yeah.
Again, you have taken a session in for the Bangladeshi community in probably 2017.
Yeah. It's quite
Almost
long
five
time.
years.
Yeah. Yeah.
And we are very much happy that all of you is with us, and he is very much active in the community, and as well as the very much helpful for the professionals of the who are working on Microsoft development track. And today all of will take a session, and we are very much grateful to all of and that he has uh, he had agreed to take a session for the Bangladeshi community. Actually, I am not. We think that it is not a single local event now, as it is in online and everyone from everywhere can join in the session. Actually, it's a global session.
Yeah.
Sometimes I feel. What do you think, Alok?
Yes. Now the COVID changed the pattern how we used to
Right,
work in
right.
community and companies as well. So there is now no boundary, and we are get
Right.
much more like involved with these onlines. So it's really easy one for everyone.
Actually, after COVID, one thing is good happened that before we are arranging events in physically, and it's too